Write it down.
Alright. For the first section, you needed to factor out a GCF, so what they have in common. For these two, you can divide a 3 out of both, so that was part of your GCF. They also both have x's, so that also had to be part of your GCF. So 3 and x. And when we divide out 3x, what's left? Plus 2. X squared. So however many x's there are, make sure you're doing one less. So if there was 3, now there's 2. If there was 1, now there's none. Questions on the first one? On the second one, these all have one thing in common. What can we divide out of each of those? 2. They're all even numbers. These do not all have an r, so you should not have any variables with that. And if we divide each one by 2, what's left?
3r squared plus 2r plus 6.
3r squared plus 2r plus 6 would be left. What questions do we have on that one? Make sure you're paying attention to what the directions say. If it just says factor out a GCF, that's all you're doing, nothing more. I will say with your GCFs, if it has a negative, make sure you factor out a negative and then be careful with your signs. If it has a negative with the first term, I should say. Right. For the second one, factor with grouping, you should have 4 terms. Some of these, you may be able to factor out a GCF at the beginning. Some, you may not see that, but then you end up with something that you can factor more. I'll show you an example of what that would look like. Okay, so here, we're going to split down the middle. What can we divide out of these first two? 5. And what else? B. And how many B's?
2.
So B squared. Make sure you're doing the highest number and the highest number of variables we can take out. If we divide both of these first two by 5b squared, what's left? 5b. And then by the second two, or by, I'm sorry, by the second two, 1. Positive 1. And then what can we divide out of the second two? 6. Positive 6. Whatever this is, bring that sign down. If we divide both by 6, what's left? 5d plus 1. Then our last step, take what's outside, put those in a factored form together. So 5b squared plus 6. And then take the other terms, what's inside, put them in a factored form together, but they're the same, so 5b plus 1. That would be your final answer. What questions do we have on that one? If, let's say, you got down to your final answer and you had something like 30b squared plus 6. Is this completely factored? No, we can divide out another 6. That means if you get something at the end that looks like this, you can factor it out again. Do that. Factor it out so that it's completely factored at the end, which really means you had a GCF for all of the terms at the beginning, but you missed that. Just do it at the end. And that's it.
What does the last level say?
It's a 1. This is way too thick, but this should say plus 1. But that was just an example. If you get something at the end, double check your factors, make sure you can't factor it out again. Okay, let's do the second one. Same thing, split it down the middle. What could we divide out of the first two? 4 would work. I think that's the highest. Yeah. And then m squared. And what would be left? Seven m plus 4. And then what could we divide out of the last two? 3. But this is negative. Whatever the sign is, bring this down. This would be -3 that we're dividing out. What would be left? 7m plus 4. Then we need our final factors. What's on the outside becomes 1, so 4m squared minus 3. And then what's on the inside becomes 1, 7m plus 4. What questions do we have on that? For the third objective, you're looking for perfect squares. So make sure that these are perfect squares. If you're not sure, put it in your calculator and do the square root of 25. The square root of 1. If you get whole numbers, I did. If you get whole numbers, those are perfect squares. If you don't get a whole number, that means you may need to divide out a GCF before you can get a perfect square. So if these are perfect squares and your variable is even, you can go directly into your two factors. What times what will give you 1? 1. What times what will give you 25? 5 and 5. What times what will give you x squared? X times x. And then 1 should be plus and 1 should be minus. If you don't have a perfect square, divide out a GCF or see if you can divide out a GCF first, and then you should be able to get your perfect squares. What questions do we have on that? Okay. 49 and 9 are perfect squares, so I know I'm going to have two factors. One's going to be plus, one's going to be minus. What times what will give us 49? 7 times 7. Now, a to the 4th is even, so we can split that directly in half, divide it by 2, which would be a squared. And then what times what gives you 9? 3. Okay. I do want to mention this. Whatever order this is in, notice how here our variable comes last and here our variable is first. Make sure it's in the same order. Don't switch these and put 5x minus 1 because that's not the same.
And the sides, like, they don't matter which way.
No, I can put plus first and then minus. It does not matter. Okay. Other questions on that? Okay. For the next objective, for the first one, There are two different ways you could go about doing this. You could do this method, the same method as this, so if the second one will do it that way. It is a little bit longer, but it still works as long as everything is right. So you'll see that here in a second. But we're looking for two numbers that multiply to be negative 15, but add to be 2. So think of your factors of 15. 5 and 3. Would negative 5 plus 3 give us a positive 2? So if we switch them, negative 3 plus 5, that would. So with these, you're going to have two factors. Whatever the variable is going to be the first term in both. And then you're going to take the two numbers you just found and put those in. So m minus 3 and m plus 5 are your two answers. What questions do we have on that? With the second one, look and see if it has a GCF first. It does. So we'll do it with the GCF like you saw it and like you didn't see it. So if you see that this has a GCF, go ahead and divide it out. So you would have n squared plus 2n plus 1 left. Now the inside of this looks just like this other one, which means we're looking for two numbers that multiply to be 1, but add to be 2. 1 and 1. They would both need to be positive. We would bring down our GCF. We would still have our two factors, where n is the first term in both, and then plus 1 plus 1. Now, if you did not see that it had a GCF, then you would be doing something like objective 5, which is fine. So we would take 5 and 5 and multiply them together. And now we're looking for two numbers that multiply to be 25, but add to be 10. What two numbers would work? 5 and 5. If they're both positive. So then we would need to rewrite this using both of these. So the first term would stay the same, 5n squared. We would put in our middle two terms, but this middle term had an n, so this also needs an n. And then our last term. If you write out something like this and you see all these 5s, there was definitely a 5 we could have factored out. It's okay if you don't, as long as you do it at the end. So then we could split the middle. We could divide out a 5 and an n out of the first two, which would leave n plus 1. Out of the second two, we could divide out a 5, which would leave n plus 1. Then on the outside, we would have 5n plus 5 and n plus 1. Here, is as I'm looking at this, I can still divide something out of this, the 5, which means I could have divided that out at the beginning, but that's okay. As long as it gets divided out somewhere, you're good. If you don't see the GCF, it does become a longer process with bigger numbers. So if you have something with bigger numbers, there was most likely a GCF. What questions do we have on that one? For the last objective, the method we just did, we're going to be doing that here. Look and see, does it have a GCF? This one does not. So we can go directly in, take 2 and negative 20, multiply them together. So we're looking for two numbers that multiply to be negative 40, but add to be negative 3 or subtract to be negative 3. You may need to list out your factors for any of these. But what two numbers would work? 8 and negative 5, would that give you negative 3? Switch them. Oh. Negative 8 and positive 5 would. You were right with the numbers, just not with the sign. Also be careful with that. Ask that question to yourself. If I add these together, will they give me this number? Because the factors may be right, but to multiply, but they may not be to add. And that could throw everything off. So from here, we're going to rewrite this. 2r squared stays the same. Put in the two numbers you found with the variable. So negative 8r plus 5r minus 20. From there, split the middle, start factoring by grouping. So here we could take out a 2 and an r, which would leave us with r minus 4. Out of the second 2, we could divide out a positive 5, which would leave us with r minus 4. And then our final answers would be 2r plus 5 and r minus 4. If it does have a GCF, make sure you divide that out and keep it all the way through. Don't lose it, otherwise it changes the answer. Before we do the last one, do we have any questions on this or that process? Need more than that, let me know. Alright, last one. Here, this does not have a GCF, so we're going to multiply 6 and 8. So we're looking for two numbers that multiply to be 48, but add or subtract to be negative 49. When those two numbers are close, it's more than likely going to be whatever and 1. So here, if I have negative 48 and negative 1, those would subtract to be negative 49. So don't forget that one. Everyone forgets that factor, those factors. And then the process would be the same. Make this 4 terms, 6t squared minus 48t minus t plus 8. Split the middle. So this, factoring out of the first two, we'd have 6t, which would leave us with t minus 8. What can we divide out of the last two? We could do 1. We could always factor out a 1. And this is negative t. This t. I'm making it longer so it doesn't look like a plus. This minus t. This is that arrow. That's supposed to be in here. Right, so if we take out negative 1, then t minus 8 is left. And our final factors are 6t minus 1 and t minus 8. Do we have any last minute questions on any of this? When we get back from lunch, we'll be starting the tests. So make sure you get any last minute questions you have asked and clarified before that